No issues either. So hi, I'm Akbar. Very nice to meet you. I'm co-founder of a company called Logger Data. As I explained it to Tomi, we're a development tool for firmware engineers. So we make it. We like to think of ourselves like an API for development hardware. So if you're an engineer for writing firmware, you can do all the things you used to do, like flash your board and probe it with the oscilloscope, whatever, without having to physically have access to your board. Everything can be done remotely via an API. So with that, I'll go ahead and share my screen and get started. Let's see here.
Yeah, fantastic. And hey, everyone, I'm Daniel Price, co-founder of Ioterra, and feel free to pull in close here. These workshops are a lot more intimate than the main stage chat, so feel free to share questions at any point. We're really lucky to have Akbar, as you said, co-founder and CEO of Logger Data here, just a wealth of wisdom in product development firmware, dealing with crazy IoT product deployment stuff that happens in the field, and this should be a really interesting workshop. So thanks, Akbar, and back to you.
Yeah, thanks, Daniel. Okay, so today's workshop, my workshop is, imagining the IoT toolchain of the future. So the reason I say imagining of the future is because right now we're still kind of using, the classic toolchain that everyone probably is familiar with, GDB and UART and, all those kind of tools. But, what we're seeing is kind of like a golden age of embedded systems. So in the last, I would say 5 years, we've seen an absolute explosion of the number of lines of firmware in a given product. We've got, everyone's predicting that everything's going to be smart. You're going to have an MCU, and basically, your pen is going to have an MCU, and your bed's going to have an MCU. But so really what we're seeing is that in embedded systems, especially, in the IoT industry and smart product, we're seeing that what used to be a hardware-centric industry is now becoming a software-centric industry, just like everything else in the world. Like software is kind of king now in embedded systems also. But our tools are still shockingly out of date, right? GDB dates back to like the 80s, UART, like 70s. We don't have, there's not a lot of out-of-the-box test automation like there is in the software world. Very limited collaboration tools. And a lot of that has to do with, because, we still have to deal with physical hardware. It's not like, in software where you can just, spin up a VM or, a Docker container or whatever, and you've got your whole, environment that you need. So there's a real reason why we still have, an old tool chain. But now that software is like I said, becoming the rock star of our industry, we need to kind of think about like how do we support the fact that, there's going to be more and more firmware embedded software written in this space. And the way I like to picture it is, right now we're, if you guys have ever seen Twins, we're still kind of like the Danny DeVitos in terms of the tools we have access to. And, all those people in the web world have, amazing tools and things to kind of do their work. So trying to figure out how to, this workshop's kind of imagining, what the future would look like. And real,
By the way, let me step in real quick, Akbar. Sorry.
Yep.
For any of you who don't know, Akbar's sharing his screen, and so if you see the video at the top, you can maximize it because he's got some really awesome slides here showing Danny DeVito. So you hit that double arrow on the top, and that'll maximize the screen that we're talking through right here, in case you didn't know.
Anyway, so why is the debugging, modern IoT so hard? I mean, I think the first thing is that the number of, lines of code that we now have to deal with is 10x bigger than, back when I started, back in the early 2000s. And that's kind of because, if you just follow like Moore's law, you can just put more code on a chip. Back in, 2000, a PIC 16, had a few hundred bytes of RAM and maybe 1,000 bytes of EEPROM or ROM or whatever. So you just, you literally could code review line by line your whole application and find bugs by reviewing it. But now, you've got multiple people. Your firmware team is probably 3, 4, 5 people. You've got constant pull requests. There's just no way to manually review all the code all the time and find bugs. You have COVID kind of accelerated this, but I think this trend was already happening where you have very distributed teams because it's just hard to find. It's getting harder to find. There's so much demand for firmware engineers that teams have to look further and further abroad to kind of build out a team that can do what they want. modern IoT, you'll have a Bluetooth stack, you'll have a USB stack, you'll have a Wi-Fi stack, you'll have, the number of communication protocols that teams are dealing with is growing. Security, everyone knows this is an issue, but I don't know if we quite realize just how big of an issue it is. But that's also another thing that's making debugging IoT modernized. So especially given all the, in fact, Internet of Things, right? Like these are by design networks, devices, but we're still coming from a historically embedded systems are kind of like closed off systems, so we don't really have a security mindset yet. And unlike a lot of web products, not only do we have real-time requirements, but we still have strict power requirements. So you've got all this, you've got security, you've got communicate, like way more code, and then you've also got these physical things that just makes it in general way harder than it used to be. So one of the things, I think the big things that's going to change in the coming years is that we're going to start, our tool chains themselves are getting more and more unwieldy. And there's actually this great thing, tool that I think most of you are probably familiar with, Docker, or containerization, right? Whether it's Docker or some other technology. And I think most people still think of containerization or Docker as kind of like a web tool or software tool. You write some web application, you run it in a Docker container, then you deploy those Docker containers to web servers all over the world. But it's actually an amazing tool for IoT developers, embedded system developers, because it's a way to manage your embedded tool chain, which is getting more and more complicated, right? Before you just had a compiler and an IDE, but now you've got your compiler, you've got you've got Python as part of your thing, you've got a Flash tool, you've got all these additional tools as part of your tool chain, and as our teams grow bigger, managing these tool chains is becoming a real pain point for a lot of teams. And just to kind of review what containerization is, traditionally when you want to work on, you go to GitHub, you want to work on a project, you clone it, and then you're like, okay, I got to install, to build this project, I need to install a GCC, ARM9 EABI GCC, I need to install CMake, I need to install a Ninja. To flash it, I need to install it to NR52, so I'm going to install NRFJ Pro. There's all these programs you're manually installing, and hopefully it all just works. Hopefully you don't have something else already installed that's messing up your path or your environment, and then you have to do kind of IT. That's the traditional way that most people get started on a project, I think people are probably familiar with virtual machines, and it's like, okay, well, you could just spin up a virtual machine and kind of do that manual process once on a virtual machine, and share the virtual machine. But virtual machines are very resource intensive, and you might have multiple development environments. You wouldn't want to have 8 virtual machines running on you probably couldn't even run them in parallel. Whereas containers are very, very lightweight. So the idea with containerization, and Docker is the most popular version of this, is that you basically can put everything that your project needs in order to build it, to flash, to test it inside of a container. And you can have multiple, you might be working on 4 different projects, each with a different build, tool chain that have different, maybe one requires Python 3.8, but one's a legacy project that still needs Python 2.7. And, managing that locally could be challenging, especially now that, Python isn't being supported, 2.7 isn't being supported. Whereas you could just put that in a container, and you've got that forever, and it's not going to change no matter what you install on your computer. Even if you get a new computer or switch from Linux to Mac or whatever, you kind of have that build environment forever. And it's a nice thing, it's really lightweight, so you're not going to be using a ton of resources. And so in the future, what's going to happen is you're going to go want to work at a project, you're going to go work at a new company, and they're saying, hey, here's our repo, or in all our submodules, clone them, and then here's a Docker image, and you're done. There's no like, oh, install this set of tools and do this, and it's like you're just gonna Docker pull and git pull, and you're basically done. And that's basically I think one of the this is my favorite part of the future of IoTs, and I already do this with all my projects. Is none of my projects have local tool chains. I put everything immediately into a Docker image, and then it's easy for me to share it. It's easy for me to maintain it. There's no risk of updating Python locally and breaking my entire tool chain, or updating GCC or something like that. It's going to always work. So I think that's going to be definitely one thing that we're going to start seeing more and more in the future of IoT. So anyways, right now, if you're a hardware team making an IoT device, it's really hard to have a truly distributed. If your team is all over the world, it's a huge pain point. But once you can, kind of virtualize away hardware, and I don't mean like simulation.
Hey, let's see, Akbar, did you sign back in with your email? I'm going to adjust the microphone so that it's working for you, because right now you're not broadcasting. Just a moment.
Okay.
And all right, so then step up close to the mic and you should be set. Perfect.
Okay.
Got it.
Okay. So anyways, and when I say like a virtualized connection to real hardware, what I mean is that we still need to use real hardware. Like that's still key to being able to develop IoT and smart products. We're not, I think, really close to a world where simulations can replace the hardware. Companies spend millions of dollars on Simulink and MathWorks, licenses to kind of simulate that kind of stuff. So the trick is kind of doing what, like I mentioned before, is what Amazon is doing for web developers, which is like, hey, there's still real physical hardware here, but how do we virtualize that interaction so that, as a developer, you can do everything you need to do without having to like find a spare board, or especially with the apocalypse that's going on right now, where hardware is in high demand. This is going to be a real key to letting teams move forward. One thing that's also very near and dear to my heart is automated testing, but hardware in the loop testing. I think especially in our field, testing isn't done nearly as much as in traditional software fields, because the infrastructure required to do automated testing is expensive, right? Because you have to get a rack of hardware and somehow hook it up and connect things together in a way that isn't as simple as just spinning up like I said, an AWS server or a Docker container. But in order to all these kind of address all the things here, security and power requirements and real-time requirements, you can't do this manually. Our products are way too sophisticated today to manually test everything every time you want to do a pull request or merge. And what I'm seeing a lot of teams doing is that they just don't kind of do the, they do a pull request. Someone will manually look at the few lines of code that got changed. And maybe there's some unit tests running, on an x86 machine somewhere, but no one's doing this kind of automated hardware in the loop regression testing that, I believe is required as we build more and more sophisticated things. Because you can imagine I wrote some code, and it's completely unrelated to battery management, but maybe I have maybe I'm blinking an LED and I'm doing it in a really dumb way, like with a while loop that just blocks, right? And all of a sudden I've broken our power budget because of that. But if you were to look at just the fact that the LED is blinking, you'd say, oh, my code works, right? So hardware in the loop regression testing is going to become extremely important as we start developing these more modern, sophisticated products. And there's already a ton of resources for us to do that, right? There's GitLab CI/CD, there's Bitbucket pipelines, there's Jenkins, that's been around forever, GitHub Actions, and all these tools are kind of agnostic. They're like, I don't care if you're a software team or an embedded team. This is a really easy way to set up CI for free, basically. So the trick is then how do you hook those things up to physical hardware? But I think once we figure that out, teams will be testing 24/7. They'll think back to when a world when we did do this, and be like, I can't believe we did so little testing, and the little testing we did was manual. Like someone would literally go through a checklist on a spreadsheet before doing a release or whatever. And so anyway, that's one thing I think is going to happen more and more. And then the last thing, this something is really frustrating to me is that in our industry, how siloed our data is, right? Like if I want to, if I'm using an oscilloscope, all that data I'm getting from the oscilloscope is stuck in the oscilloscope. There's not like an easy way to just grab it and share it and store it and all that kind of stuff. Same thing with like I'm using a logic analyzer or debug, whatever it is. You've got all these really expensive, advanced, sophisticated tools, but they were built for a different time where data wasn't, it was kind of like you would manually look at the scope screen and okay, like that looks like a clean signal, or that's a noisy signal, or that's not working right. There wasn't this thought like, hey, like maybe this data needs to live in the cloud, like share it, I can store it, I can come back to it, I can replay it later if I want to, relook at what I'm seeing. Again, we need to break down these silos and figure out how to take all this. We generate so much data during development. How do we, unsilo it, get it out of the silos that they exist in, and basically have it so that they're available all the time to anyone who wants it. And I think when data is free, you're going to see things that we didn't even think about, right? All of a sudden now we enable data scientists, and QA can do a lot more interesting things with the data that we're being generated than what we're able to do now. So anyways, that's kind of my take on what I believe the future of development will look like in this space. And again, that's a lot of this stuff. Almost everything on this list is stuff that Logger, my company, is addressing. How do you use Docker more easily? How do you have all these data streams that are not stuck in their tool that you can easily share with people, virtual connections to hardware, all that kind of stuff. So we're actively working on realizing this future. But this kind of stuff is what I've been thinking about for years. As an embedded engineer, is like being able to. I remember I was working on a project, a company called Ringly, and it was this small little Bluetooth enabled ring. And we were trying to get accelerometer data off of it, and it was a nightmare. Like wiring it up and then getting the data off of our laptop into a place that everyone could use. I mean, all the kind of things that we just kind of like suffer through are real impediments to us, moving faster and doing cooler things. So
awesome, fascinating talk, Akbar. And I've got a question. But I also want to open it up to anyone who's joining us in the audience to, we've got a couple minutes now to ping Akbar's brain on anything you might be wondering about. So I can kick it off. I'm curious for your perspective on this. Like, firmware has been so different historically than software or other cloud side development. A, because of the silo. B, because there's just different languages that people are coding in, right?
Mm-hmm.
It's limited in what you can do in 500 megabytes in assembly code or C code. Do you see software development in general and firmware kind of converging, and it's the same types of developers that can develop on any of these systems, or do you see firmware kind of remaining a bit of its own specialty and discipline?
I think it's gonna, it's always gonna be a systems language, right? Because you don't have you have things like FreeRTOS, and there are more and more tools for people who are writing embedded systems. But end of the day, it's kind of like you're a systems developer on a computer writing kernel stuff. You kind of have to be a little bit more responsible than an application, someone writing an application with Python or whatever, because you do have access to the bare metal. You're doing things like driving motors and reading sensors, and so I think you're always going to be a little specialized, but I think with like languages like Rust and Zig, which I'm a huge fan of, you're starting to see slowly but surely people are realizing that C isn't the be all end all. Kind of like assembly to C. I think that was a quicker transition, although there are still people. I remember back in early 2000s, people were like, I don't do C, I only do assembly. I don't trust C. It's like, okay, if that's how you want to live your life, that's fine. And I think we're starting to see now the beginnings of people moving off of C to things like Zig or Rust. And I think those languages are modern languages that will allow people to kind of move back and forth between like, okay, half the time I'm in Zig or Rust, half the time I'm in Python, but they're both, they both kind of have modern features that I can use on both sides. But fundamentally, they're going to be different, right? Where one's embedded systems, I think for a long time will be a compiled language, because you kind of need that speed and that efficiency versus something like versus an interpreted language.
Yeah, that makes sense. And historically, I mean, the diehard assembly folks, like back in the day, there was no surplus available whatsoever for any inefficiency in the code, right? And as computing capability has increased, like the microcontrollers now are maybe a little overpowered for a lot of the applications they're in. You can be operating at a higher level and not have to worry about bringing out every last efficiency drop. And I think that's what's enabled some of these new technology advancements.
Absolutely. So I think two things. One, I mean, our compilers are also amazing today. Like I think it's not even realistic for a human to write better assembly than a compiler is going to compile down your C code. But the other thing is, because these processors are way more powerful, you can be like, I'm going to write more readable code, more maintainable code, because I don't have to like eke out every little thing, even though by the end now my code only I understand what I'm doing. So it's like you can optimize for maintainability and not for efficiency, because our MCUs are so powerful. And I think that's going to be a huge win too, is that you can just write modern software, whereas 20 years ago you were like, okay, I'm gonna do everything I can possibly can to save a byte here or a byte there from the code size.
Cool. Any other questions for Akbar as we wrap up, guys? And by the way, if you did want to ask a question, you'd have to approach the stage, either Akbar or me. Cool. Well, Akbar, how does everyone learn a bit more about logger data and dive deeper into what you're talking about today?
Yeah, so we have a booth with a bunch of links, I think, in the booth. But if you just go to loggerdata.com/field guide, that kind of ties into our talk, which we have a field guide on our site, which is us kind of like writing about what we think, like using Docker, using a lot of stuff on Zig actually. So it kind of goes through like our take on the future in our space. And then if anyone's interested in a demo, I love demoing the platform. I can show you some of the stuff live, like what we've been talking about today.
Awesome. Wonderful. Thanks so much. Really appreciate the insight, and thanks everyone for joining in.
Yeah, thanks, Daniel. Thanks, everyone. Bye.